All right, Jim. So we've seen some really cool announcements of some R&D coming out of Georgia Tech, the Athena lab at Georgia Tech. They've been developing some technology to try to harvest the RF energy that comes out of the new 5G network. Obviously, 5G is a major wave that's coming with smaller cell networks that are able to do a lot more data transfer and provide a lot of really interesting technology. And they're actually becoming real networks in large cities like Chicago and San Francisco, New York. So, what do you think about the ability to harvest meaningful amounts of power for IoT? So, let's talk about really small, kind of low power consumption devices. But what do you think about the ability to harvest power off of these and this really cool research coming out of Georgia Tech?
Well, I applaud Georgia Tech for looking at this. This is kind of a new and growing area, and it always brings up questions about, what else can you do with these new technologies as they evolve. I'm a little bit concerned about it based on the history I have working in the cellular industry for 30 years. My gut feel is I don't think Verizon or AT&T tried to design their 5G networks with
Hmm.
the idea of harvesting power on IoT devices. They have a big task in front of them to try to turn this into a high bandwidth communication device.
Right.
Um, Typically, 5G systems are designed to have just sufficient amounts of power to be received by a cell phone, an IoT device for communications. So they're really targeting to get the energy above the thermal noise of an antenna at these receiving devices, which is going to be quite small. So there's not a whole lot to really harvest there,
Yeah.
unless you're very close, very line of sight. But even then, it's a tall order to turn that into something that may be functional, unless it's an extremely low power that's needed by the IoT device.
Yeah, that makes a lot of sense. And I love reading the research and hearing the press releases that come out of real academic labs that are cutting edge. But sometimes there's a reality of how far into the future are they working. And it seems to me that in this case, Georgia Tech is doing what sometimes Georgia Tech does, which is do things way out in the future. I really applaud the fundamental research and the opportunity to see things that have less directional requirements than a typical harvester or a typical RF system might have. So I think that they're doing some really cool things. But just break it down for me in power levels. What types of power levels do you think are realistically possible with a nicely focused, very efficient receiver utilizing 5G?
Well, I think the way they set up their link budgets is to have receive powers, better than -70 to -90 dBm. Again, that's 7 to 9
Hmm.
orders of magnitude below a milliwatt of power.
Yeah.
Um, if you get close to, a cell site, typically you might see on the order of -20 to -30 dBm. So you're 2 to 3 orders of magnitude below a milliwatt, which means you have to amplify that signal 100 times to get up to a
Wow.
milliwatt of power, which is very small for charging. Maybe acceptable for some IoT devices,
Yep.
depending on what those devices are. So, in the absolute ideal conditions, it is within the realm of possibility.
Yeah, so there's a lot of physics that's still left on this bone to be make this realistically possible. Sounds like we're in realistically nanowatt territory. I think most kind of passive IoT devices that I'm familiar with are require at least tens of microwatts, usually more like milliwatts, tens if not hundreds of milliwatts to start becoming, powerful enough to gather whatever data they're trying to gather and then also link it back to the cloud or whatever they're using to mine the information that's gathered by the sensors. So again, I don't want to come off negative on this at all, Jim, because the role of academic labs, in my opinion, is to push on things that don't seem possible. So today, I think the viewpoint is that we're maybe talking about nanowatts of power, and this might not be the way. It's not the way that a Verizon or an AT&T or a Qualcomm is designing 5G networks to be utilized. But if it was possible to get milliwatts of power off of these without having to consume a lot of energy to get it there, that could be a game changer for these distributed sensor networks. And I think that that's very promising. And so I commend Georgia Tech and other labs that are pushing the gas pedal down to try to get some of these breakthroughs in physics that are necessary to make that type of future possible.
Sure, and there's always, that's what academic labs, research labs do, is go down the alleys nobody else has quite gone down before,
Right.
and look under the the dark covers that previously people look at them and say, well, it's not feasible, and you may need one or two breakthroughs to make those feasible, and they're looking at things like unique types of antennas, ways of lensing the power to try to increase it as much as possible. So
Yep.
so let them keep going, and wish them the best.
Yeah, definitely. If our friends at Georgia Tech are watching, good luck. Keep pushing it. Anyone else in academia or at national labs, we love it. Let us know if we can help you on giving you a vantage point. We're cheering for you. We love this stuff, and keep pushing it.
Absolutely.